Okay, so the chemical properties of the elements are largely determined by the number of valence electrons that they have. That's why it's important to tell the valence electrons from the periodic table. So we've seen that the number of valence electrons corresponds to the group number, and that's why all the elements in that group have similar properties. So in group 8A, everybody except helium has 8 valence electrons. So that highest level being completely full, we've got the S and the P completely full, that's an especially low energy state. And things that are lower in energy are more stable. So the noble gases are very stable chemically. They don't react. Some of them don't react with anything at all, ever. So if you have elements that have electron configurations that are almost noble gas configurations, those are going to be very reactive because all they need to do is change a little bit and then they can become extra stable. So in my chemistry land, where I make analogies and crazy things, I think of these noble gases as being the really cool, popular kids in high school. Those kids that, everything seemed to go right for, and they got invited to all the good parties and everything, right? And everybody else, well, not everybody, but a lot of the other people in the school wanted to be like those people. And so that's what happens with people dressing alike in high school, right? Somebody starts out wearing Hollister hoodies or something. That's what, when my son, who just got married, was in high school, that was the thing. Hollister hoodies. So you go to school and everybody's being an individual by wearing a Hollister hoodie. Kind of silly, huh? But the cool kids were wearing those, and so everybody wants to look like the cool kids, right? So you dress like them. Doesn't make you cool, but it makes you maybe feel a little cooler. So the electrons are on the outside of the atom, right? So they're like the clothing of the atom. Atoms can gain or lose electrons in becoming ions. It doesn't change what element they are. The number of protons is the soul of the atom, and that's who it is. The number of protons doesn't change. But they can change the electrons. They can change their clothes. So we look over here at the group 1A elements, the alkali metals. These are very reactive elements. They react with water, and so they're just really, really unstable. Let's think about sodium. Sodium has 1 valence electron, like all the rest of these. If sodium loses that 1 valence electron, then what does it have? Well, let's look at that. So sodium would be 1s2, 2s2, 2p6, 3s1, right? That's sodium. If we get rid of this electron, this is the same as the electron configuration for neon, right? Looking at that, how many valence electrons? 8. So by losing 1 electron, sodium can have the same electron structure as neon. Does it turn into neon? No, but it looks like neon from the outside. It has become more stable. So sodium tends to react in a way that it loses an electron and achieves the same electron configuration as neon. So all of these tend to lose 1 electron. We learned in nomenclature that all of the group 1 metals form positive 1 ions. We didn't understand why. It was just because the teacher said so, right? They lose 1 electron and become a +1 ion because when they do that, now they have 8 valence electrons like the previous noble gas. The group 2, the alkali earth metals. All of these have 2 valence electrons. So they have 2 electrons more than the previous noble gas. If they lose 2 electrons, then they have the same number of electrons as a noble gas. Losing 2 electrons makes you a +2 ion. Group 2 metals form +2 ions. They do that because they become more stable that way. Any questions? We can learn the patterns without understanding, but the quantum mechanics explains why the pattern is there. The halogens, group 7A. These guys have one electron less than the noble gas next to them. Right, here's fluorine. It's got 7 valence electrons. The next one over is neon with 8 valence electrons. So fluorine doesn't want to lose an electron. Fluorine's going to gain an electron. Gains 1 electron, it becomes a -1 ion, and now it has the same electron configuration as the noble gas. So all of these halogens will do that. So here we have a periodic table showing elements that form predictable ions. So these guys are all going to form +1. Because losing 1 electron, it becomes like the previous noble gas. These guys form +2 ions. Group 3 forms +3 ions. Then we've got the halogens. If they gain an electron, then they're going to become like the noble gas. These guys need to gain 2 electrons. These guys need to gain 3 electrons. So metals that have predictable charges are groups 1A, 2A, 3A, and zinc and silver. 1A, 2A, 3A, zinc and silver. And we can predict the charges on these. It's best if you think about, well, gaining valence electrons, to have 8, etc. But you can also do this by thinking, well, if I'm playing a board game, this is my starting point. So if I start here and I want to know what the charge on sulfur is, I'm going to count backwards. Backwards is negative, right? So -1, -2. Sulfur is going to have a -2 charge. The next one over is -3. Now, there's nothing listed in column 4 because those guys don't form predictable ions. So we're not going to worry about those. You won't end up seeing them. Any questions?